Welcome to this explainer. Today, we're skipping the basic biology lesson and diving straight into the mechanics of the Amazon rainforest. We're going to explore how this place operates, not just as some vast passive wilderness, but as a highly complex, interconnected biological engine. We'll be digging into the data, the surprising history, and the staggering mechanics of a system that literally breathes for our entire planet. Just picture it, a relentless green ocean stretching across South America, literally pulsing with moisture and sound. It's this massive living labyrinth that's been pulling in carbon and breathing out oxygen for over 50 million years. Every single leaf out there is essentially acting as a tiny solar panel, and every root is acting like a lung.
To really wrap our heads around the sheer size of this engine, just think about this number, 2 million. That's 2 million square miles. It's an immense footprint that practically defies human comprehension, draped like a giant, living blanket over the continent. And inside that massive 2 million square mile footprint, we hit another metric that's honestly hard to believe: 1 in 10. This single ecosystem shelters 1 in every 10 species known to science. It's this unstoppable force of biodiversity that actually dictates global weather patterns and guards our planet's carbon vault. So let's jump right into part 1, Rulers and Unseen Architects. It's fascinating to see how this incredibly dense system actually maintains its balance. It does so through a cast of extreme characters, and power here takes on totally different forms. On one hand, you have the solitary jaguar, relying on pure, raw force with a skull-crushing bite. And on the flip side, you have the tiny leafcutter ant, relying on masterful design and collaborative precision instead of brute strength. What's absolutely wild is the sheer scale of the leafcutter's unseen engineering. A single colony can move 12 tons of vegetation in a single year. But get this, they don't even eat the leaves. They use them to farm a living fungus. And even crazier, they naturally produce antibiotics on their own bodies to keep mold off their crops. They literally figured out medicine millions of years before we did. Now, on the other end of the insect spectrum, we have the bullet ant. If the leafcutter is all about design, the bullet ant is pure, raw defensive power. These guys are nearly an inch long, and their venomous sting is so agonizing it actually holds the #1 spot on the Schmidt Pain Index. It's so intense that it was historically used in indigenous endurance rituals. Let's shift our gaze way up into the canopy. Here, life slows way, way down. The algae-covered sloth lives its life in absolute slow motion, basically blending into the green light. But about once a week, it makes this careful climb down to the base of its tree to defecate. That waste goes straight into the roots, directly feeding its own home, and closing this perfect self-sustaining loop. But, moving that slowly definitely makes you a target. Enter the harpy eagle. This apex predator absolutely rules the air. It weaves through those dense branches with an incredible economy of force, striking totally unseen with talons that literally match a grizzly bear's in size. It's the ultimate example of the sudden, lethal efficiency you need to survive above the canopy. Which brings us to part 2, the language of survival. Or, as I like to think of it, the evolutionary arms race. In an ecosystem where practically every shadow is hiding a threat, survival turns into this high-stakes arms race, and it basically breaks down into a few extreme languages. You've got lethal venom and chemistry. Then you have the masterful trick of camouflage, like the glass frog, which is almost entirely transparent. And finally, you have the absolute manipulation of physics and color. Speaking of color, being visually brilliant in the Amazon is never just for show, it's utility. Take the toucan. That massive, vibrant beak actually pulses with blood, acting exactly like a radiator to cool the bird down in the intense afternoon heat. Meanwhile, the heliconia flower uses its bright reds and yellows as a highly specific beacon, perfectly evolved just to grab the attention of hummingbirds. Sometimes this biological engine even borrows its weapons. Let's talk about alkaloids. The famously bright poison dart frog, it isn't actually born venomous. It concentrates its lethal chemistry entirely from the toxic bugs it eats. In fact, if you raise these frogs in captivity and feed them a normal diet, they completely lose their deadly defense. Then the sun goes down, and deception gets vocal. The margay is this small, super agile tree cat. It can rotate its ankles a full 180 degrees to climb headfirst down a trunk. But its real party trick? It mimics the cries of infant monkeys. It literally tricks highly intelligent adult monkeys into rushing right into its grasp. Pretty wild, right? Okay, let's move on to part 3, humanity's forgotten imprint. Here's a historical twist that kind of rewrites everything we assume about this quote-unquote untouched wilderness. The most surprising architects here aren't animals at all. 65 million years ago, this whole basin was an inland sea. But fast forward to the ancient era, and modern LiDAR has revealed vast human engineering. We're talking geometric flood-resistant causeways and huge road networks. This landscape was actually deeply shaped by massive, thriving human civilizations. And these ancient societies didn't just survive the jungle, they actively upgraded it. They created something called terra preta, or dark earth. By mixing charcoal, bone, and organic waste right into the soil, they engineered this incredibly rich fertilizer that also locked carbon into the ground. It's so effective that centuries later, farmers today still seek out these dark patches because crops grow so much stronger there. And this deep connection isn't just ancient history. Today, indigenous groups like the Huaorani people of Ecuador continue this exact balance. They read the forest through sound, scent, and shadow. They show us that surviving in this extreme environment is not about conquering nature at all. It's about engaging in a deep, respectful conversation with it. All right, part 4, the heartbeat of our planet. Let's look at the Amazon River itself. The main artery powering this whole system, pumping water and nutrients across an entire continent, is the Amazon River. And the numbers here are just mind-blowing. 29,000. Every single second, the Amazon dumps over 29,000 cubic meters of water into the Atlantic. To put that into perspective for you, that's more water flowing out every second than the next 7 largest rivers in the world combined. Because of that massive flow, this single basin holds about 20%, a full fifth, of all the fresh water on Earth. It feeds thousands of tributaries across 9 different nations. If you look at it from space, it looks like a giant silver serpent. It's a living force that fundamentally stabilizes weather systems across the entire globe. And the reason this massive scale actually functions is because the forest operates almost like a collective intelligence. Think about the builders, like macaws, who mate for life and coordinate their flights high above. Then you have the recyclers, like king vultures, who swoop down to clean away decay before it can poison the earth. Every single creature is playing a totally vital, interconnected role. So, bringing it all together, we have this enduring engine. Despite very real modern threats, advancing chainsaws, organized poachers, devastating fires, this unstoppable natural machine keeps working. It's still out there, absorbing billions of tons of carbon, exhaling the oxygen we breathe, and driving global weather patterns every single day. Because the forest's health is, at the end of the day, the planet's memory, I want to leave you with a thought to really ponder. How well have we learned to live with what sustains us? It's a crucial question about our own connection to the survival of this biological engine. Thanks so much for joining me for this explainer. Keep asking those big questions, and I'll see you next time.